Welcome to APH Access Academy, the first in our series of On the Road to Code. Today is CodeQuest, and I am going to turn it over to your presenter, Leslie Weilbacher. Take it away, Leslie.
Thanks. I'm Leslie Weilbacher. I am the outreach specialist for the Northwest region of APH. That's big chunk of the US and our US territories in the Pacific Ocean. I have been a TVI for the last 6 years, an O&M specialist, and I'm now concentrating on assistive technology. And also with me is Zhou. Lee, do you want to introduce yourself?
You'll need to unmute, Lee.
Lee, you're muted.
You can hold down the space bar.
We'll give him a minute. He's having some mic issues. It happens every once in a while.
Yeah.
There you go, Lee.
Can you hear me now?
We
Yes.
can.
Oh, sorry, guys. Okay, I'll introduce myself again. My name is Zhou. I'm a product manager at APH. I'm the product manager of this app, CodeQuest. So I hope you will enjoy the session today and like this app. Thanks.
Thanks. Okay. Okay. So let's talk about our objectives today. First, we will reinforce voiceover gestures such as split tap, tap, drag, double tap, and the picker. Build vocabulary for coding concepts such as sequence, putting steps in an order, first, second, third, last. Debug, finding an error and fixing it. Loop, an action that is repeated. And 3, practicing math skills of counting, problem solving, and grid coordinates through planning out the astronaut's path to the ship. Counting the right number of spaces and avoiding the wrong way. So if you want to play along with us, you can, if you have an iPad, you can go to the App Store, search CodeQuest, and download it. It is a free app. Lee, was there something else you wanted to add about that?
Yeah, at this point, this app is for iPad only, but we know some students are still using their iPhones and even iPod touches. So we do plan to make this app also available for those devices as well. So it is on our list. At this point, we don't have a clear timeline for that, but I don't think it will take us very long. So
awesome, that's good to know.
Mm-hmm.
And then I believe we have a quick poll question.
Yeah, so for our poll questions, our first poll question we have today is, what is your comfort level with coding and coding concepts? So 1, you're excited, but you don't know where to start. 2, you're interested, but a little overwhelmed. 3, very comfortable and ready to go. Or 4, not so comfortable, but I want to support an interested student. So you can go ahead and put your answers into the poll. And if you can't, for whatever reason, access the poll, if you want to drop your response into the chat, that is also great.
And I would just say, as a TVI, this is certainly not an area that I felt my education had prepared me for, but I had a strong interest in it. And I'm just so lucky that I get to focus on it now and really explore it. So do not feel like you have to be a math whiz or something to to really get a lot out of this.
We're about at 45% of the participants responding. So I'm going to go ahead and end the poll for time's sake and to share out the results. So for the majority of you, 44% said you're excited but don't know where to start. Followed by 25% of you said you're very comfortable and ready to go. Next by not comfortable, but I want to support an interested student. And lastly, we have 13%. We had 2 people saying interested but a little overwhelmed. So there we go.
That does not surprise me. And I definitely got started with this because I had an interested student. And so I had to start figuring out a way to make this work for that student. So why computer science in general? Well, 51% of US high schools are offering computer science courses. And I have here a pie graph that's half gray and half orange showing half of US high schools. That's huge. That's a huge number. So it's out there. You're going to run into it. 39 states have CS standards written in. 23 states have mandated CS courses in their secondary programs. So this is a major part of our lives, especially, I mean, we wouldn't even be communicating this way if it wasn't for computer science, right? We wouldn't have this reach out through Zoom. Now, there are some AP computer science classes in high school, and that can lead to 130 career areas and 48 college majors. And that is according to the College Board. So that is a huge opportunity for students. We have a need for diversifying the field. And there's tons of job opportunities. This is a very fast growing area. And it's fun, quite honestly. I find it fun. And these are these statistics I pulled from code.org.
Leslie, I'm going to ask a quick question from the chat. I believe Lee might be able to answer this. There's a question about, will this be available for the Braille Note Touch Plus at some point, which I assume they're referring to on the Android platform. Is there any plans to develop this to be available on Android?
At this point, we don't have a plan, but you can request. You can just let us know, and if we do receive many requests, we can definitely develop an Android version. Technically, there's no difficulty with that. There's no difficulty developing the Android version.
Oh, that's good to know. Okay, so where am I?
The benefits of computer science.
Okay, great. So multiple studies indicate that CS education can help students beyond computing. CS education has been linked with higher rates of college enrollment and problem-solving abilities. Short introductions to coding can help some students feel less anxiety and gain interest through things like the Hour of Code, which is through code.org. CS education promises to significantly enhance student preparedness for the future of work and active citizenship. And all of that is from an article from Vegas and Fowler of the Brookings Institute. All right, so what is coding? Coding being a part of computer science, or CS as I've been shortening it. So in short, it's a language we use to communicate with computers. we give computers instructions, commands, and they follow through. So this is logical ways of understanding things around us and solving problems. Kids learn that the program does exactly what you told it to do in the exact order it is written. Now, this is an image of a block language, a block coding language, which most commonly you will see in apps for kids. It's still coding, it's still a language, but we've combined it, they have combined it with this image, and they're very similar to puzzle pieces. They latch together if they work together, and it's a very visual thing. So let's see. Go to next slide. So coding for students who are blind or visually impaired. Most coding apps for kids are not accessible with animations. They want to make them interesting for kids, so there's lots of cartoons, there's lots of movement, there's Flash, there's this block coding language. There's instructions to read. It's not usually voiced, and it's not usually accessible with a screen reader. I'm saying usually because I'm sure there's something out there that I haven't come across that it does work, but I haven't found much in that realm. So this block coding language, it's a drag and drop interface. So you go over and you choose which one you think is going to work. You drag it over, you line it up, and it'll connect if you get it close enough. So lots of spatial. But our students need the same opportunities, the same access to learning opportunities as their peers. Not just for the career interests and opportunities, but because it is what is being taught in school, and they deserve to have that equal opportunity. So let's look at what this particular app is. The background of CodeQuest. CodeQuest started as a computer science student team project led by Diane Bronner at the University of North Carolina. Several teams and several semesters later, the proof of concept app was shared with APH, who took over the app, field tested, modified, and released into the App Store. A doctoral student who was also at the University of North Carolina created 3D printable materials to go along with the app for the arrows, the characters. And then APH added embossable grid layouts for all of the levels. Lee, since this app was handed over to you, do you want to add anything there?
Yeah, actually, you pretty much covered everything. Like Leslie said, when submitting the app to APH, Diane and her team already had a pretty much functioning prototype. So after we received the idea, we at APH just took the prototype, kind of finalized the code, and also updated some sounds and graphics. Then, like Leslie mentioned, we did a field test, a group of TVIs and students nationwide. I think probably, if I remember correctly, more than 15 teachers and more than 50 students nationwide tested the app and also give us lots of comments and suggestions. We then did make a few changes according to teachers' feedback and then release the app to the store. Yep.
Awesome. Okay. So transferable skills. You can reinforce O&M skills with route planning and mental mapping and spatial relationships. right, left, up, down, and problem solving. I'm going to build confidence with math concepts like grids, rows and columns, logical reasoning, step-by-step thinking, and practice iPad gestures, the layout on screen, and ear cons, which are sounds as meaning. So Lee, you had mentioned to me before, why is it important to know the layout of the screen in terms of coding?
Yeah, actually, we know for programmers, when they develop apps, they not only need to write codes behind the scene, they also need to develop user interfaces. I know some of you may say, you know, blind programmers generally do not design user interfaces. They rely on their sighted colleagues to do that. That is true, but they still need to understand the layout in order to make their code work well with the interface. So understanding the graphical layout on the screen is very important. Students here using this app can drag their finger tips on the screen to understand the relative locations of the items. For example, if I touch a label on the screen, I will know that the label is located at lower right corner. If I touched two buttons, I will know which button is at the top, which button is below it. So that graphical information is really important for blind users to understand the layout. I know some blind users often just enjoy swiping horizontally to move their screen reader focus from item to item. But doing that, the information you get only, it seems to be linear. It does not let you understand the graphical layout. So really putting your fingers on the screen will be really beneficial for blind students. And this app gives students the chance to practice that skill.
And that leads really well into O&M skills. So a lot of these, as you will see, overlap each other. Knowing the relationships between objects on the screen, in O&M, we also need to know the relationships between object to object, our bodies to objects, our bodies to other bodies. So this is another great aspect. So here is an image of one of the levels in the app. We have our little astronaut in the top left corner and our spaceship in the bottom right corner. There's two paths to get to the ship. One is shorter, but has a wall to blast through, and one is shorter and has two walls to blast through, and the other one only has one wall to blast through, but you have to use 5 blasts to get through it. So we have some choice making here. So we're looking down on the map for the astronaut's route, and we have to write the directions for the astronaut to get to the ship. And we may have choices of which way to go, but we want the shortest path. And this map is laid out on a grid, which leads into math concepts of what is a grid. So a grid is rows and columns. All of these maps or mazes are laid out on a grid, and I'm going to say that a lot of times. And this is something to get some good practice on early, because this comes up a lot in math. We will, the astronaut in this is always row 1, column 1, which is always the upper left-hand corner. The ship is often in the furthest corner, but not always. The ship moves around. What else? The path changes, the obstacles change. We will hear the coordinates from for the ship and the astronaut at the beginning of each level. In this one, the ship is in row 3, column 5. Now, grids are used in a lot of math and science tasks, but Lee, how is this a little different from what we might see as far as like a coordinate plane?
In mathematics, when we talk about coordinates, we often have the origin at the lower left corner, so lower left corner. This one is a little bit different. Like Leslie just mentioned, we always start at the upper left hand. So it's a slight difference. But this experience playing this game does give students a way to generalize their understanding. I think we'll provide students with a basis for their future math understanding.
Yeah, definitely. Just the concept of rows and columns, and it comes up in other things than math, but I recall in 8th grade doing a scatter plot and it being a very nebulous concept to me because it was very visual and I didn't have a good tactile representation or even just a good mental picture of what that is. So this is one way to help start that process. And next we have our iPad skills. So the gestures that we will use are tap, double tap, split tap, which might be a new one for some people. It's where you find what you want to activate, hold your finger on it and tap with another finger. And that's useful if you have to press it multiple times. Also swipe, dragging our finger around the screen, which is something else we want to do in somewhat of a grid pattern, or at least a methodical search pattern. And the picker, which this is an image of the timer app, and setting the time on it, you do a very small flick to rotate through the number choices, and that is called the picker. Okay. So let's actually play. Let's actually do this. The mission of this app. So we're following our little astronaut, but we are the programmers of the spaceship's computer, ZX5. We program the directions the astronaut needs to get back to the ship. And there's 5 planets to explore. So I'm going to quickly switch over my microphone, but I don't want to don't want to mute myself. I want this. Okay, hopefully. 12:20. CodeQuest. Can you see my iPad?
Yes.
Awesome.
Play. Tap play. Back button. Back button. Solar system. Buckle up. It's time to.
Can you hear my voiceover?
I can hear it. It's a little low, but I can hear it.
Let me just check. Oh, might help if I press the right button. Oh. Okay, that should be it. All right, here we go.
Back button. Solar system. Buckle up. It's 3, 2, 1.
5 new planets were discovered at the edge of the known universe by scientists from the Intergalactic Space Agency. You must now use the remote interface to your ZX5 computer to reach your ship and return home. Select a planet and start playing.
Okay. So the next thing is vocabulary. So just to reiterate our vocabulary that we're going to focus on that is directly related to coding is sequence, which is step by step or putting steps in an order. So first, second, third, last. This is a very useful skill in a lot of realms, but in this, we have to make sure that we put our code in the correct order. Debug, so that is finding an error and fixing it. If it didn't work, we have to figure out why and how do we fix it. Good problem solving skills. Loop, an action that is repeated. So, you know, with walking, you repeat the same action as moving your feet until you get to your destination. Okay. So, example planet. So we're going to use the iPad skills of dragging our finger around the screen to get an idea of what our planet looks like. We will use split tap to add our commands by holding one finger on the directional arrow and tapping with another. We're going to use our math skills for counting and working through this grid. Now, in coding, you start at 0. So the astronaut is at 0, and every space to the ship and including the ship, we're going to count. I am going to
12:30 p.m.
share my iPad again. Maybe. There we go.
12:30 p.m.
There we go.
App switcher. CodeQuest.
Okay.
CodeQuest.
So I'm going to
Back button.
choose the first planet, Kratos,
Planet Kratos.
or Kratos,
Level 1.
and
Your
I'm going to choose level 1 of our 6 levels.
This is your ship's computer. ZX5. I need you to return to me so that we can fly back to our home. To reach the ship, count the steps you need to move and move that many steps to the right.
Okay. So those are our instructions. And now when I press the start level button, it is going to give us the coordinates of where the astronaut is and where the ship is. So we have to listen carefully.
Planet Kratos. The level is 1 rows and 5 columns. The astronaut is located at row 1 and column 1. The rocket ship is located at row 1, column 5. There is no alien in this level.
Okay. So this is the very, very first level. It is very simple. We have 1 row, 5 columns. To get an orientation of the screen, the top half of the screen is our map. The bottom half of the screen is our coding area. So I'm going to take my finger. I know my astronaut is in my upper left-hand corner, so I'm going to start there. I'm going to
Astronaut.
astronaut.
Column 1. Empty. Row 1. Column 2.
So it's empty directly to his right.
Empty. Row 1. Column 3.
It is empty beyond that.
Empty. Row 1. Column 4.
It is again empty.
Rocket ship.
And
Row
there's
1.
the
Column 5.
there's the rocket ship. So if I wanted to
Astronaut.
count, I'd go
Empty.
1,
Empty.
2,
Empty.
3,
Rocket ship.
4.
Row 1.
So I need
Column
4
5.
to the right. The other sound that I think you should hear
Astronaut.
is that means there's nothing there. That's empty space. We sort off into space. We don't want to do that. And that is an example of an ear con. So we are using a sound to represent something in this instance. The same goes for our directional arrows. So down at the bottom of the screen, we have our row of buttons. We have a yellow one that's for
Up left button.
left,
Up
a
button.
blue one that's for up,
Down button.
I'm going to call that red one for down,
Right button.
and a right button, which is purple. So we want the right one. We want 4 of those. So I'm split tapping 2, 3, 4. And that is the sound for right. There's a different sound associated with each button. Kind of like the swoosh when you send an email. There's certain sounds that are associated with different activities. So just so you can hear it,
Left button.
left is, that's a pretty short sound, kind of like the ding. Notes for left and right. And then
Up button.
up is kind of a longer sound.
Down button.
And down is also kind of a longer sound, and it goes down in tone. So I'm going to
Erase button.
erase those real fast. Oh, and we have an interesting sound for erasing as well.
Right.
Okay, I was just double checking that I got it right. Now, the fun part begins. There in the bottom left, we have a button to run our code. So we can press go and our astronaut will make it back to his rocket ship.
Play button. You win. You took 4 steps. Your best performance is 4 steps. You got 3 stars. Congratulations.
Okay. Now, in some levels, there's different ways to do it. So you might get fewer stars if you choose the longer way.
Play
All right.
again. Button.
No, I don't want to play again. I want to go back to my PowerPoint. And let's talk about moving and sequence. So in Kritos level 4 is a good example. So if you're playing along with us, you can choose the first planet, the green planet, Kratos, and choose the 4th level. And so one way to explain the movement of this astronaut to students is you could say, well, how do astronauts move on the moon? They hop. If you ever watched any videos of Neil Armstrong on the moon, he hops because there's less gravity. So in this mapping out in a grid, our astronaut moves one space at a time. He hops between each square. Each press of the directional arrows tells him hop 1. So 1 to 1. In this level, we have some twists and turns and a possible wrong turn. Does anybody want to try and write the code for this? You can put it in the chat before I give you the answer. I'll just give you a second. I will just describe this some more. This is a 4x4 grid. Right below the astronaut is unbreakable walls. To the astronaut's right is 1 square that you can move into. And then beyond that, they're unbreakable walls. The Rocket ship is in the bottom right-hand corner, so row 4, column 4. Any ideas of the answer? Should I move on? All right, I'm going to go on. So here's what this would look like. This astronaut would need to go right 1, down 1, down 1, right 1, right 1, down 1. And that looked like, would look a lot like this. You'd have a purple arrow, you'd have 2 red down arrows and 2 right purple arrows and a final red down arrow. And so that is putting, but if we didn't put that in the right sequence, if we put one of these out of order, he would run into a wall and it would not run correctly. He will do exactly what is written here. Okay. So we'll jump on to the next planet, actually going to jump to the 3rd planet in our new little solar system, which is the planet Attis, level 2. And we're going to talk about problem solving and debugging. Now this is a 6x4 level, and the rocket ship is in row 2, column 6. And now we have something new. We have walls, and these walls you have to use the new blaster button to break through. Let me clarify that. We have walls that you can blast through as opposed to unbreakable walls. And those in this case are orange and they have the number 1 in them. So that tells us it needs 1 blast to break through this wall to get to the ship. So the shortest route to get to the ship has 2 walls you have to blast through. There is a route you can take without blasting through walls, but it's much longer. So what is a bug? When we talk about bugs in computer science, a bug is an error. If it doesn't work, it's a bug. When professional programmers write code, they need to work out bugs too. It happens. The most important thing to remember is continuing to try things even if it doesn't work. You get to find that bug and fix it. Mistakes are part of the learning process, right? Now, the term bug really came from a bug in a machine. In the 40s, a group of scientists were working on a machine, on a computer, and something kept not working, and it was working the day before. And they finally started just to take the machine apart to see maybe it blew a circuit. They literally found a moth in the computer. There was a bug in the circuitry. So we still say that today, which I think is kind of funny. Does anybody want to try and solve this level? You can throw it out in the chat. The new blast button is to the right of the purple right button, and it is kind of orange and has maybe a cross or a star on it. So I'm going to give an example of a bug. So, oops, I wrote some code. I thought it was right. I ran the code and my astronaut ran into a wall. Does anybody have an idea? So I'll read this out, but if anyone has an idea of what I did wrong, please shout it out. So the best path to take would be a straight line across the top, blasting 2 walls, one wall at row 1, column 3, and the other at row 1, column 1, 2, 3, 4, 5. And then down 1 on column 6. So my astronaut made it to row 1, column 4 and got stuck at that second wall to blast through. So I went right 1, blast, right 1, blast, right 1, down. I'm missing something in this code. So I'm going to go and say, got it. And the correct answer is right 1, blast, right 1, right 1, blast, right 1, right 1, down. Now, the mistake I made is I lumped something together. I thought because pressing the right button made him go to the right 1, that pressing the blast button would blast through the wall and he would move into that space. That was not correct. I was assuming the computer was going to fill in a blank for me, and it did not. I had to tell my little astronaut to continue to move forward after that wall was blasted through. Okay, moving right along. Now this is loops, repeat movements, loops. We're jumping to another planet. This is Pollux level 3. And we have another new button. We have now a loop button, which is a green button and a circling white arrow, and there is a number 2 on it. Now that is the button where we're going to use the picker gesture. If we want to change that 2 to a higher number, to loop more than just that 2 times, we will bring the focus to that button and flick up or down if you want to reduce it. So that's where we will use that picker gesture. And that has appeared next to our blast button. So now we have lots of input to put here.
Leslie, we had a question in the chat that I think would be timely before we move on to the loops. They wanted to know, does the blast have to be assigned a direction by the user?
Oh, that is a really good question. No, as long as your astronaut is right up against the wall that can be blasted through, the blast will hit it. So that actually is a good question that Lee might be able to add to, because our astronaut does not turn. You tell the astronaut to go to the right. He will go to the right. He will not turn directionally and then go to the right. If that makes sense.
Yeah, that is correct. Mm-hmm.
Yeah.
But yeah. Mm-hmm.
So let's see. So the point of loops in a coding capacity is to shorten the code, to make the code more efficient. So if you're telling your astronaut to go multiple times, you're pressing that right button 5 times, that's a lot of effort for one thing. Whereas you can press that button and then press the loop button and change it to 5. So it's a more efficient way of writing code, and it is used, it's used for all sorts of things, but you would repeat the loop for a set value number of times, or until something else happens. We're not really able to show the until something else happens scenario with this app, but typically an example would be if you're walking, you repeat left, right, left, right, left, right, left, right until you get to your destination. So you don't decide I'm going to take 10 steps. You stop walking when you've reached your destination. What we're able to show here is a set value. We're going to take 10 steps. Okay. Okay. That is what I have there. So let's move to, this is the answer to the level with no loops. It takes 12 steps to complete this level. That is quite a long string of code. It is down, down, blast, 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 right, right, up, right, right, down. So that's especially the blasts, because this wall that we blast through requires 4 blasts. So let's look at what it would be like with loops. It's 6 steps. That is half the amount. When you use the loop, the number appears on top of the direction or the blast. So the blast here, the blast button in the code section has a 4 written on top of it. So going from 12 to 6 using loops makes it a lot easier to read off. You can say down 2, blast 4, right 2, up 1, right 2, down 1. Much easier. Okay. Now we have a poll question.
Go ahead and launch this question for everyone. So we wanted to check in. How are you all feeling at this point? 1, I feel a little bit better about pursuing this with my students. 2, great, I want to learn more. Or 3, I'm still a little bit confused. Answers are pouring in. Shooting for half. And just for time's sake, I'm going to end the poll now. And so in our responses, we have the majority of folks, 75% saying, great, I want to learn more. We have followed by 19% saying, I feel a little bit better about pursuing this with my student. And we had at least one respondent who was still confused.
That is okay. That is okay. I went through stuff fairly quickly. And it's not even everything. There's I chose 3 vocabulary words I felt I could explain in this format easily. There's other things you can do. And there's more to come. I will move on to say here is a review from a high school student. This is actually my my intern. And she says, I know this is for younger kids, but my friend and I had a lot of fun. The app is very good for teaching younger kids and even older students the code, how to code and the basics. It is good for not moving too fast at one time, and I found it works easier if you try one step at a time. If the one you try doesn't work, you can erase it. And actually, I didn't tell you that you can erase it, but you can. there is a backspace button and a clear all button. There's also a cursor button, so you can move the cursor in directly to the spot in the code. You don't have to back up all the way through it. So a couple of pro tips. You could utilize a computer science journal to keep track of the process. Write it down, practice your Braille or touch typing. Use the 3D printed materials if you need that connection, that tactile connection. It's a great thing to do. Emboss the grids. They're very simple embossing. You do not need a really fancy embosser that does tactile graphics. They should be able to be embossed by most embossers. You can make cards for the directions, blasts, and loops to keep track of the code. So you decide you need to move down one, you could pull up a down card and put it in front of you to remind yourself that's what I'm doing. And that's another way you could tie it to Braille use. And you can use other tactile elements to work out the path. So I will talk about a couple of those really fast. The Picture Maker Wheaton tactile diagramming kit, you can have your student draw the grids with this. You can say, okay, this is a 4x4 and the ship is on row 4, column 3, and they can decide what shape means what. You can also use the graphic aid for mathematics, which is a black rubber gridded mat that they're smaller grid spaces, but you can use thumbtacks to push into it. You can use rubber bands or pipe cleaners, whatever works for you, just to give you that spatial awareness. Or you can use the hundreds board with manipulatives. You have the grid laid out with the Velcro, and then your student can choose, okay, the star is the astronaut, the triangle is the rocket ship, the circle is a breakable wall, the square is an unbreakable wall, and just practice those grid coordinates. You could just shout out like you're playing Battleship. Row 2, column 3 is a blank space. Okay, so blast off. Now that you know basically how to sequence and debug and use loops, what's next? Next month, March 10th, we will be continuing on the road to code with Colby, the Code and Go mouse. And then the following month, April, we will continue with Code Jumper. The exact date is TBA at this point, but it will be in April. And this road leads to the National Coding Symposium in May, the week of the 9th. So again, join us next time for Code and Go Mouse. We can meet Colby, and I will be working on a specific bridge from CodeQuest so that these build on each other. That is my hope. And let's see. I am rapidly running out of time, so I'll just, if there's any questions, I can throw that open. I do in this PowerPoint, which is on the website for free download in an accessible format. I have pages of my references and some resources, both for coding and APH in general. You might want to check out our Excel academies, which are going to be on after school hours and weekends for students. They're both live and recorded. And you can get, yeah, that's. Lee, did you want to add anything in our last few minutes?
Yes, I'm good. I know in the excuse me. I know in the chat, Diane listed the websites for some videos showing the app. So just if you are interested, just go to those websites and check the videos there as well.
Yes, on Paths to Literacy, Diane has
Yeah,
several very good articles. They are in my resource slide as well, if you missed that.
We have a couple more minutes if there's any questions watching the chat. I'd like to thank everyone for participating today. Any other questions before we start to wrap up? All right, so I'm going to go ahead and pause the recording at this time.